because it's much easier for us to be able to check the charts if you just read the answers as opposed to me calling out all these answers. All right, there are the answers. So check and see if you got it right. I gotta see if I managed to get Power School to come up. Yeah.
Okay. Oh my goodness,
Go fast. All right, what things do we need to do? Anything on that that's bothering us that we can't do? I don't hear any voices out there that say yes. No. So any of those types of questions, if they're on the quiz, everybody's going to do them right because we know what we're doing.
Wait, I got a question.
Yeah.
Okay, so you know how 2 and 3 already have the symbols to it?
Yeah.
Are we going? What is that?
We're at.
Like 2 and 3 for carbon and chlorine?
Yeah, this is just hyphen notation there. So that's just C-12. Sometimes they'll use an abbreviation for it. Instead of writing the word out, carbon-12, they'll just put C-12. That's the same thing. And which other one? 3. That's just without putting the number at the bottom because they didn't want to tell you what the atomic number was so that you'd figure it out yourself. That was it. All right. Anything else on that page? All right. So we can talk about the ions now? Okay. All right. I'll put that one back in here. And I don't think I need a document camera. All right, I feel like I'm at the grocery store. There we go. All right, so this one, I'm going to find a sticky note. Question 1. We're going 1, 2, 6, 7, and 9. So question 1, you should have 26 protons, 23 electrons, and 32 neutrons. Number 2, 16 protons, 18 electrons, and 16 neutrons. And 6, 7 protons, 10 electrons, 7 neutrons. Number 7, you should have, let me get rid of this and pull up. because these are easier to write to show you. All right, so 7 would be Zn. We're going to have a 65 and a 30 and a plus 2. And 9 would have Mg with a 24 and a 12 and a plus 2. Okay? Questions? Anything on any of the 5 on ions that you don't understand? You want to ask me? I got to talk about. Yes, ma'am. Okay, talk this way so I can hear you.
Number 7 and 9, like, how do you figure out you're supposed to have plus 2?
Okay, so when you look at this, can we agree that you have 30 protons and you have 28 electrons? Okay, that they're different. All right, so as long as these are different, you're going to have a charge. Can we agree on that? All right, when they're the same, there will not be a charge here. Now, because they're different, you're going to subtract these two numbers to find the charge. So when you subtract, you get a 2. So that's what tells you the charge here is going to be a 2. Now, which is bigger, the protons or the electrons? All right, so what charge do protons have, positive or negative? That's why we put a plus there. So if we look at number 8, for example, okay, what's bigger, the protons or the electrons? The who? Look at 8. The electrons. All right, so subtract the protons and the electrons. What do you get? Okay, so the charge is going to be a 1, and which you said the electrons are bigger, so we're going to put a what on that sign? So we're going to put a -1 on it. Okay, that's how you would decide the charge. Okay. Questions about anything with the ions? Anything on the topics that we worked with yesterday bothering you before we do the quiz? Anything? Okay, you need a writing utensil and your periodic table, providing you didn't take notes on it yesterday. If you did, you need to borrow one from me. Okay? Periodic table. Oh, and you have a calculator. Most of you probably won't want to subtract or to add. Okay? Oh, he's going backward. Got to put it on.
Split it up, they did this side, and then they took out this side. And then I was also to this side and take out all the rest of it.
But you got it.
And now all like white.
He got dropped. He said that he got
All right, put your name on the paper. Make sure your answers are legible. You make sure 9s and 4s are easy for me to read. All right. Does everybody have a quiz paper? All right. You done? Just flip it over. Good morning. I don't mean to get this. You weren't here. You need to get the notes. And maybe you were a forward thinker and you already got the notes and did everything. If you did that, it's fabulous. But you still need time to absorb farming. Did you get the notes and everything?
Well, just think all the day. I had a migraine.
That's fine. Get the notes and then you can go to. Just hang on to it. You guys just flip it over. That's my clue that you are finished.
Ms. Wall,
Yes, ma'am.
can you send Tomas Dunval to the office? He's signing out.
I will.
Thank you.
Welcome. You done with the quiz? You done with the quiz? Yes. Put it here, put it on my desk. I'll give you the sheet, and that way you can just get a chance, watch it on YouTube, so you know what to do. Maybe you're still working. I can't tell. 1, 2, it's about 5 or 6 are cracking. I'm sorry. I didn't see it. What's wrong?
Branches outside.
Yeah. How about now? How many folks are still working? I got two. Okay. About now. We're still working now. All done? All right. Guys, stretch to the front and say who's going to pick them up. You're like, God, a little stress.
It's more for the street.
Okay.
I'm trying to refrain.
Are you doing this?
You know, some days I feel like I just talk to hear myself talk. Sit one. Does anyone remember what I said?
I forgot.
The whole incident.
I said this week and next week. And does anybody remember what days I said? Tuesday, Wednesday, and Thursday. This week and next week. So would that be today? So feel free. I will be here. Was here yesterday at 4:30. I had probably, I don't know, how many we have, Celia? How many people do we have here yesterday? It was a lot, probably 10 people here. So if you are free and want to come by, come on by. If you don't, that's okay too. All right, it's up to you. You choose. So, you need today a calculator and a periodic table for today. So if you do not have those things out, grab one. And you notice, we're going to do math all day today.
I got that
Okay.
next period.
Huh?
I got that next period.
Got it this period too.
I got chemistry.
Oh, and you're going to need the back side of your homework sheet from the one that has a table on it. You're going to need the flip side also. So find that. Because we're going to use it. So find those things for me. All right. We'll do the back side of those. Now, yesterday, we talked about isotopes, right? Yeah, we did. What are you talking about? Nah.
Oh, I was talking to somebody else.
Oh, okay. yesterday when we talked about an isotope. Okay? What did we say an isotope was again? When the what?
Protons and electrons.
Protons are the same. Yes. What's different though?
Different number of neutrons.
Neutrons. All right. So in an isotope, you have the same protons, but you have different neutrons. So the example I gave you yesterday is like carbon 12. All right. And the other example I gave you is carbon 14. But carbon actually has 3 isotopes. There are those. Okay? Now, 99% of all the carbon on the earth is that one. Okay? Carbon 13 only has a trace amount. And roughly 1% is carbon 14. So, when we look at the periodic table, we have to put the atomic number here and the atomic mass down here, right? Now, when I put that atomic mass down there, how many numbers do I get to put down there? One number. But the problem is, I have how many different types of carbon? I got 3. I only get to put how many numbers here? I only get to put 1. I don't get to put 3. So what am I going to do with all 3 of those numbers? I got average. Okay? I got to put an average there. So, how do I average their numbers? Do I add them all up and divide by 3? Okay? So if I say 12 plus 12 plus 13 plus 14 divide by 3. Okay? I ain't too good with my math, so I'm going to walk over here and get my calculator. It's 13. Okay. That's what I thought it was. So if I do that, check your periodic table. Is the mass 13 on the periodic table? Dang. Why not? Let me ask you this. In my class, are all grades created equal? Miss Lee's back there nodding. It's not. Because if it was, what would count the same as a test grade? Homework. Or those openings. We're going to collect openings on Friday. You don't have to get an opening question right. And you can make 100 on the openings. Because what do we do every day after we do the openings? You go over them. And then you could do what? Write it down. And then turn it in. Now, is it fair that that would be equal to a test grade? No. So when we average the atomic mass that goes on the periodic table, does carbon's same weighted percentage as carbon 12? No, it does not. So, mass on the periodic table is based on percent natural abundance on the earth. So carbon-12 has a larger percent abundance on the earth. It gets a larger weight when we average its mass. Just like in my class, what gets the largest weight in the average? Does anybody remember? Tests. Tests are 50%. They get the largest weight in the class. So when I average, they're set up to average at 50%. So we'll have about 5 over the course of the quarter. So by the end of the quarter, 50% divided by 5 is what? 10. So each test counts how much of your overall grade? 10%. So those of you who are debating, test corrections or not, this test will weigh about 10% of your overall grade. So if you're okay with what you have, counting 10% of your grade, don't do test corrections. If you're not okay with what you have, counting roughly 10% of your grade, then do test corrections. That's how you decide in a weighted average whether you need to do test corrections, because that's what it's going to count by the end of March-ish, roughly, middle of March, I think is when we end. All right? So how are we going to calculate this? All right? Mass is, let me change colors so it's a little light. All right, mass is equal to, take your mass, you say average mass there because that's what we're looking for. Average mass is equal to mass times percent plus, my plus a little bigger there, mass times percent plus dot, dot, dot. Divided by 100. Now, what do these dot, 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 dots mean right there? Anybody know?
All of the different, like carbon 1, 2, and 3.
It means those parentheses continue for like a carbon 1, 2, and 3. So I only have 2 sets of parentheses, right? But these 2 sets of parentheses are identical. So that means plus, you would just do another set of parentheses that looks the same. If you had 4 isotopes, you would need how many of these sets of parentheses? 4, okay? So, we're going to do a real example with this. But this formula can perpetuate itself with these numbers of parentheses for however many isotopes you have, okay? Does that make sense? But anytime you have a formula that stops with a plus sign and has dot, 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 dot at the end of it, it means whatever is here just keeps going, okay? One of the ones that we're going to have later in the semester says PT equals P1 plus P2 plus P3 plus dot, 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 okay? So what happens at the plus sign? What happens when you get there? So it says P what after that? P4 plus, and so forth and so on, okay? But if you only had 2 pressures, you would stop where? You would stop at P2, okay? It just depends on how many you have. Everybody got it? Okay, I know it's raining today, but y'all seem kind of dead. All right. I'm pretty sure I have average mass problems already done, so I don't have to. Yep. So I don't have to create these. All right, so let's say, and I'll give you a minute to write this down, that we have an isotope of chlorine, okay? And chlorine has 2 isotopes. We're going to start easy. Because the biggest challenge for students on these are the calculator. It's not setting up the problem. It's punching it in the calculator. These problems have more calculator errors than anything else. On the quiz that we will take, let's start Tuesday, Wednesday. What's today? It's Wednesday. We'll take it Friday. Okay? So our Friday quiz on this and the stuff we're learning today, this problem has more calculator errors than anything else. Everybody sets it up right, then does it wrong with the calculator. If there are mistakes. All right, we there? Okay, so when you got it, Xavier. All right. So, how many isotopes do we have? 2. So, how many sets of parentheses are we going to need out of our formula that we just wrote down? We're only going to need 2. Okay? So, and then divided by 100. So, it's mass times the percent that they give you. So, the mass of my first isotope is what? 34.969. And what's the percent natural abundance of chlorine? 75% of all of the chlorine on Earth is the 34.969, or the 35. Now, the rest of the chlorine on the Earth has a mass of 36.969, and its mass, or percent on natural abundance on the Earth, is 24.23. Now, this one only has 2 parentheses, so this one should be a pretty easy one for us to do. Now, because we're multiplying and dividing, and we have a big add sign in the middle of this, can I skip my parentheses? No, you cannot skip the parentheses keys here. If you got something close to what I got. You got it on your calculator stuff? The only thing I would tell you to do different than what you did is I would tell you to hit equals before you hit divide. do that and see if it works.
When I divide, I put it all together.
Yeah, hit equals before you hit divide. You are close. My best guess with you is you changed the number. You did on that first one, you said 69. You said 34.696. You inverted the 969. That's all. You just flip the numbers. Anybody else not get it? What? Got it. Anybody else? Did that work, Smart? Are you still doing it? Okay. All right. Try that one without me doing it with you. Okay? You do it from beginning to end. How many parentheses are you going to need? You're going to need 3 because you got 3 isotopes. All right? You do that one from beginning to end. Yeah, go ahead and round. What's the least number of significant digits we have up there? So looks like this one's 2, but given we're trying to have an answer that's similar, keep it in 2 places behind the decimal. So you have a decimal in 2 places so we can make sure we're in the right ballpark for the answer and you're calculating it correctly. Yes, I need to do this too so that we know if everybody's got the right answer. Say what now? What now? Okay. All right, what'd y'all get?
Basically, that's what I was saying.
So 15.99, or you rounded it up to 16.00?
Yeah.
Okay, depending on how you rounded here and here. Okay. All right, questions? Are we all okay with that? All right, now let's talk moles.
Oh, what?
Moles. That needs to go because we're done with it. There, that's where I want to be. All right, for the next 40 minutes, we're going to talk about a topic that we are going to spend a large amount of time with the rest of this semester. It is going to pop in and out between now and June. Okay? There we go. It's done spinning. All right, so we're going to talk mole conversions for the rest of today. Now, this is a topic that after today and tomorrow, if you don't have, you need to come get some help, okay? Most of you by the end of tomorrow will be fine. So tonight, if you go home and you're doing your homework and you're a little sketchy, don't panic. By the end of class tomorrow, if you're sketchy, you need to come get some help, okay? Most of you should not be sketchy by the end of class tomorrow. Now, first of all, what is a mole? A mole is basically a conversion unit in chemistry. Okay? That's what it's designed to be, is a conversion unit. That's why there's lots of them around the room and why we have the lovely multicultural bulletin board at the back of the room. That's why it's there. It's not just some catchy little thing I have in the room. Now, what is it? Okay? It's essentially the base unit for the periodic table. Okay? Now, the element that's the base unit is carbon. All right, let me see if I've left anything out. As I get older, I tend to skip things and then I leave myself notes in the openings. See if we can avoid that tomorrow. Good there. Ah, I didn't do the definition. A mole is the amount in exactly 12 grams of carbon 12. All right, let's see if I left anything out. Nope. Got it all. Yes. Okay. Now, what are we going to do with all this junk? Makes absolutely no sense to y'all. All right, we're going to learn how to convert grams to moles because we're going to learn how to calculate lots of things this semester. We're going to learn how to write balanced equations. We're going to learn how to calculate with balanced equations. So this is just a jumping off point for us. So, starting there, what is a mole? Most of you are like, this don't make any sense. Does everybody have them one off the board? So I can turn the page, or do I need to wait? Yes, no? All right, just to tie it into something. It's a little cheesy, but think of it this way, okay? If I sent y'all to the store for a dozen small eggs, you guys would bring me how many? Yeah. If I sent y'all to the store for a dozen medium eggs, y'all would bring me how many? If I sent you to the store for a dozen large eggs, you'd bring me how many? 12, okay? A dozen is a converting unit. You guys have learned a dozen. My best guess is probably before you even entered kindergarten class, because your parents probably bought you a dozen donuts, a dozen cupcakes. You went to kindergarten carrying some kind of dozen something because your kindergarten teacher or maybe your preschool or your daycare had some kind of party, and you had to sign up for treats, and you arrived with something in your arms because you didn't want to feel left out, and you brought some kind of treat, right? Something happened, you brought a dozen of something. Now, the mole for us is just like a dozen, except it's not 12, okay? That's what we have to keep up with. Now, for us, a mole of atoms. Here, I'm going to put atoms on the end here. A mole of, let's pick an element. Let's say a mole of carbon is equal to 6.022 times 10, gotta move there, to the 23rd atoms. So it's a little bigger than 12, okay? It's huge. It'd be take the decimal out, 6022 with 20 zeros, okay? Now, if I said that we have a mole of phosphorus, how many atoms would we have? And if I said we have a mole of arsenic, how many atoms would we have? The same thing. All right. The point that I'm trying to make with my cheesy example here is it doesn't matter if we're talking a dozen or if we're talking a mole. The concept is the same. The only difference is in your mind, a dozen is 12 because you learned that in elementary school and it's easy to count or visualize 12. A mole, we can't visualize because it's a number so large, we can't lay them out on the counter and see them, okay? It's just gigantic, okay? But it is a number that is this number, and it's got a name. It's called Avogadro's number. An Italian scientist by the name of Amadeus Avogadro figured out how many of anything was going to be in a mole, and so they named it after him, okay? This number of particles, this number of anything can be in a mole. So that's the number that's going to be in there. We're going to expand on this in a week or so, okay? Just not today. Today we're only going to talk about atoms. Now, if we go to the grocery store and we're making a recipe, some recipes want small eggs because you don't need too many eggs. Now, when I buy eggs, I'm not buying small eggs. I need more bang for my buck when I make eggs in the morning, right? And I feed a husband and 2 kids. Those kids are growing like weeds, right? So what kind of eggs am I buying? At least large. Sometimes I buy extra large, okay? So they come in various sizes, right? So I can buy small, I can buy medium, and I can buy large eggs. The sizes vary. Do the sizes of my atoms vary? Yes, they do. How do we find the sizes of my atoms? Like I have carbon, I have phosphorus, and I have arsenic. How do we find the size of my carbon moles? The mass where? Very good. So, what would be the mass of my mole of carbon atoms then? 12.01 grams. What would be the mass of my mole of phosphorus atoms? 30 point what? 97 grams. I can do it in 1 decimal place, not 2. All right, arsenic would be what? 74.92 grams. Now, when you guys are writing down the masses, I don't care if you do to 1 or 2 decimal places. I typically do 1 because I know them to 1 decimal place. I don't have memorized to 2. Now, why would the masses be different? If all of the moles have the same number of particles, just like all of the boxes have 12 eggs, why are the masses going to be different? They all have 6.022 times 10 to the 23rd atoms. Why would they have different masses? Why aren't they all the same? That is exactly right. It might be the first time ever I didn't have to prod somebody for that answer. Okay? The masses are different because the protons and the neutrons are different. Now, notice I didn't say the electrons are different. Why didn't I say the electrons are different? The electrons are the same, but what do we know about the mass of an electron? It does, but what do we know about the mass of an electron we talked about yesterday? It's so small it doesn't matter. That's correct. It doesn't count. Okay? Because the mass of an electron is so small, it doesn't matter. So it doesn't matter that the electrons' numbers are different. They don't count in terms of mass. It's irrelevant. Okay? Questions so far about what we've written down? Everybody with me so far? So we're going to use this mole to convert. It's a conversion unit. This is how they're related. Every mole has how many particles? 6.022 times 10 to the 23rd. Some of you are going, oh my God, I can't remember that number. That's way too much for my tiny brain. Where are you going to find that number if you can't remember it? That blue sheet. Where are you going to find it on that blue sheet? It's the very first line on the very first page. So if you forget it on Friday's quiz, where can you look it up? On that first page of that reference table. You do not have to guess. You can look it up on that reference table right there. First page, first line. It's called Avogadro's number. In my line, Darlene, is it there? It's there, isn't it? Okay? Now, what are we going to do with this stuff? We're going to convert. Okay? So, when we convert, there's an order we can use. We have to go from grams to a what? To a mole. Now, from a mole, we can then go to an atom. Now, we can go in reverse also. If we're in an atom, we can go from an atom to a mole, and from a mole to a gram. I know some of y'all are looking at me like I'm crazy. This looks hard. It's not hard. Okay? This is why we learned the factor label method. Okay? So, you got what you need? Let's try a problem. Now, oops, forgot something. So, from this right here, what two conversion factors have we gotten out of this? All right? What's this conversion factor that we just wrote down? Okay, so moles to atoms. So 1 mole is equal to what? How many atoms? Tell me how many atoms we're always going to get. Okay, so that's one conversion factor we just wrote down. And the other one was 1 mole is equal to grams. Now, can I write a number down for the grams? No, because I think it was Justice who said this a second ago. Where did Justice get the grams from a second ago? The what? The mass. And where did the mass come from? Okay, so every time we need grams, we found the atomic mass. So you're going to need to use your periodic table. Every time. Does that make sense? Okay. Now, those three things are what we need to do the conversions. As long as we've got that, we're good to go. All right, now we're ready to convert. Now, these three things you do not need to write. I only wrote those there so I don't have to keep flipping around on the boards. You need this little light blue problem. That's it. Just this little light blue. All right, we got it written? All right, so what do we do anytime we want to convert? All right, very good, Eduardo. We want to draw the chart. So, if I draw my chart, what do I start with on the top line? All right, so what's given to me? Okay, 23.69 grams. All right, from there, what do I do? All right, what goes down here? Grams, because we want to get rid of it. All right, what do I put on the top line? Because that's what they asked for. All right, so that's step 1 through 4. Anybody lost by what your classmates did? They took what was given and they put it here. They put what we didn't want on the bottom. They put what we do want on the top. Everybody with me? Now, this is where it changes ever so slightly. We put the biggest unit with a 1, and then we filled in and counted zeros, right? I don't have to do that here. Look at the 2 conversion units we just learned. You just pick the one that fits this. Which one matches what you guys put in your table? Does the top one match or the bottom one match? Okay, so what number is beside moles? So, beside moles right here, we're putting a what? We're putting a 1 beside moles because that's what's beside moles in the conversion factor. Now, what is beside grams in the conversion factor? So, we're putting atomic mass beside grams. Now, in order to put atomic mass beside grams, you need to look it up on the... So, what element do you have in the question? So, find phosphorus on your chart, and let's write it in. 30 what? All right. Now, when you calculate, we spent, I don't know, 2 days, 3 days, practicing with significant digits, right? Now, I told you when you calculated, you only use the numbers where? In the problem. So, how many significant digits do we have in the problem?
4.
So we need 4 significant digits in our answer when we calculate. Okay? So calculate, round to 4 significant digits. What'd you get? You got what? Maybe I punched it in wrong. Let me do it again. You got what? Okay, that's what I got too, but the way some of y'all were reading that number, I was like, I ain't got that. Okay, remember, if the number is on top and the number is on the bottom, we do what? You divide. Top and bottom, we divide. Now, you can go ahead and say this number times 1, divide by this number, but if you're just multiplying by 1, is it necessary to do that? No. It's a waste of your time. But you can do it if it makes you happy. Questions about how we got the answer? Okay, let's try another one. All right, again, that stuff at the top is just there, so I don't have to keep flipping across the boards. You only need the blue. You don't need the purple. All right, we got it?
Yeah.
So, what am I doing this time?
Draw the chart.
Drawing the chart. What goes on top?
6.87 volts.
Okay. On the bottom and on the top. Okay. What goes beside moles and atoms this time? When we look up here, which one matches what y'all told me to put in the chart this time? The top one. Okay. So this time, what is beside my moles? Good. And what is beside my atoms? You can say Avogadro's number if you don't want to go that, like I think that was Samaria's voice I heard. Okay, if you don't want to just yell that, you can say Avogadro's number. All right, so when we calculate this time, all right, we have 6.87 times 6.022 times, remember hit second EE, right? Don't hit times or 23. This time I need how many significant digits? So 4.14 times 10 to the 24th atoms. And you can round up or you can just drop off and say 4.13 if you want. Any questions about that? Okay. Now, this last one, this is one that's a little different from the last two that we've worked. All right? This one's a little different. All right, we're ready? So, tell me what's different about this one and the last two. Anybody see anything that looks weird? All right, grams to atoms. And the last two, what has been in the question that's not in this question? Moles. All right, so when we set up this chart, and we have 4.98 times 10 to the 24th atoms. And you put atoms on the bottom line. All right, I want to show you something. In this question, all right, we started here in grams, and we went to moles, and we were done, right? Didn't need this. In this question, we started here in moles, and we went to atoms, and we were done. We didn't need this at all. But in this question, we're starting here in atoms, right? And we need to get all the way down here to grams. Can we just jump from atoms to grams? We need to go through moles. So, in this particular case, this is where our charts are going to start to grow, okay? We only have done a two-step chart since we started what? I guess it's only day 10. So, in the last 2 weeks. We're going to start to build our charts to grow to 3 sections today, and eventually the semester they'll grow to 4 and 5 sections. All right, so we're going to take and put what? Atoms to what's next? Moles on the top line. Now, if we wanted moles, we would stop there, but we don't want moles. We want what? So we're going to take our chart and extend the chart. Now, what needs to go on the bottom? Mole, because we need mole to cancel out, because we want what unit? We want grams. So now, we're going to put gram on the top line. Now, this time, we're going to use both of those conversion factors. We just need to put the right one in the right spot. So when we look up here, atoms and moles goes in which spot? Does it go here or in the final spot? It goes in the middle. Okay, so mole has what number? And atom has what number? Avogadro. So Avogadro's number goes here, next to atoms. Now, mole and gram has what number? Mole has a what? And gram has a what? It has atomic mass. Well, what element is in the question? So when you look up there for nickel, nickel has what mass up there? 50 what? 0.69. Okay? Now, this time, you can choose to either divide these two first and then multiply. I don't do it that way personally. I multiply across the top first and then I divide. But it doesn't matter. You can do it either way. I do 4.98, second EE, 24, and then I multiply the top. So times 58.69, and I always hit equals. Divided by 6.022, second EE, 23. And again, it doesn't matter. You can divide first and then multiply. I like to do the top first, then divide by the bottom. Just find a method you like and stick with it. Okay? So, when I do this, I have how many significant digits right here? So I need 3 in my answer. Well, I got 485 in grams. Now, some of you have probably already figured out moles is always going to have what number right now? So you're thinking, well, why do I have to go through moles? The reason is moles always going to have a 1. Oh. And if you get used to skipping moles, when moles doesn't have a 1, will you have figured out when to put moles in your chart? No. And moles will change to coefficients in a few weeks. And if you're used to skipping the moles in your chart now, what happens in a few weeks? You're going to continue to skip the moles, and you won't have a place for it in your chart. Okay? Not only that, when I ask for partial credit, if moles isn't in your chart, do I give you any partial credit? No, it's just minus 20. Okay? I don't give any partial credit if you skip moles. Any questions about that? All right. See what you can do on that one. You set it up, and then I'll work it with you. Okay? You set it up. Oops. All right, we done? Any more time? Where we at? All right, so if we look at what you came up with. All right, what do we start with? What do we start with?
Short,
Yep, what goes in the top?
56.82
Okay. And on the bottom?
grams.
On the top?
Moles.
On the bottom?
Moles.
And on the top.
Atoms.
All right. So in this first one, what goes beside moles? And because we've got moles and grams, what has to go beside the grams? Okay, so we're using sulfur. So what's the mass of sulfur? Good. All right, moles to atoms. What goes beside moles? And beside atoms? All right, people. Avogadro number. You sound like them. It's not Avogadro's number.
The Avo number.
Look now. Part of chemistry is going out of here sounding like you took chemistry and not a bunch of country rednecks who don't know how to say the words. Okay? Yes, you are. And you're going to sound like you know something when you leave. Okay? So you're going to be able to say Avogadro, not that number. Okay? Avogadro's number. So what'd you get when you calculated?
1.067
Times 10 to the 24th. Anybody else get that? Yes? Punch in the calculator again. If you got that same chart, don't have that answer. Looking at yours, I would say that you left off the exponent. Punch it in again. But you have the same work. The answer is pretty close, and you missed the E at the end. You what? You don't know the chart, the answer, the what?
How did you get that answer? What did you multiply to get?
All right. We would have said 56.82 times 6.022 second EE, and then put in the 23, equals, I always said equals, and then divide 32.07. Okay? Anybody else? Question? Yes, no, maybe? Where are we at time-wise? I got 5 minutes. Let's talk homework.
Oh,
Yes, we have homework.
homework don't even show. You get it done and you don't know what you did. Right.
All right, let me tell you which ones I want you to do. All right. Y'all are smart people. Find the bottom of that left column where it says problems. Okay? We're doing the B problems, first of all. Okay? These are not multiple choice questions. These are 1A, 2A, 3A, stuff like that. All right? We're doing the B questions. We're doing 1 through 8. B only. Now, if I check homework tomorrow, sometimes I do, sometimes I don't. It's like today. Some years I check today's homework, some years I have. This is one of those. Some years I have, some years I have. If I check, I'm expecting to see 8 what? 8 charts. Okay? I don't want to see numbers. I want to see 8 charts. Even if you don't have a calculator at home and you can't calculate an answer, I need to see 8 what? Charts. What was that? No, a separate sheet of paper is fine. I love separate sheets of paper. I can see the work. It's when people try to squeeze on this that it irritates me, and then they claim, oh, I got this wall. Here are my answers. These are my numbers. I just did it on a separate sheet of paper and I threw the work away. Okay? Separate sheets of paper are great. If you do it on a separate sheet of paper, you better bring the separate sheet of paper with you. And remember, for those of you who are struggling, today's Wednesday. I will be here if you want to do test corrections, makeup work,